Okay, so today we're looking again at the Pythagorean theorem. Hopefully this is something that isn't like shocking or isn't a totally new idea or something we've never seen before, because you should have looked at this in algebra. But our goals for today, students will be able to use the Pythagorean theorem, so nothing too crazy. We're going to be able to find missing sides. We also are going to look at the converse of the Pythagorean theorem, and then classify triangles. Pretty much by classifying triangles, we mean, are we going to be able to tell if this is a right angle or a right triangle, or is it some other type of triangle? These things that we're looking at today is split up into 2 lessons, maybe 3. 2 or 3 lessons in algebra. So it is a review, but also we're moving pretty quickly. Order of operations, if you didn't get the code, there it is again. We are going to need that for our practice problems. So what do we remember about the Pythagorean theorem?
Is that the theorem right there on the bottom?
Yes, if you graph it, that's what it looks like. Pretty crazy. Yeah? Well, yeah, a squared plus b squared equals c squared. What else can we add to that? That's what like the formula is. But what does it help us find? What does it do?
It helps you find the other side of the triangle.
Okay. What type of triangle? Any triangle?
Right angle.
A what?
A right triangle.
Yeah, a right triangle. So we have to have that right angle involved. Very good. Now, last kind of part of it, what A, B, C, like, can any of these, like, could this be A, B, and C, or B, C, and, like, does it matter?
Yeah. A and B are the legs, and C is the hypotenuse.
There we go. How do we know which side is the hypotenuse?
Let's say it's the longest.
So both of you sides are looking pretty good. It's the longest side and opposite of the right angle. Nice. That's a pretty solid review of the Pythagorean theorem. That is our first theorem. So on probably the front of both of those pages, that has the Pythagorean theorem on there. On that note, the packet, it says stuff like I can find the missing sides of a right triangle and all that stuff, and it asks you to rate yourself. You don't need to, I mean, if you want to rate yourself, you can, but I'm not going to look at that. That's just how the note packet came. So don't worry about rating yourself. It's how you feel about this stuff. Again, we use the Pythagorean theorem. We have a right triangle to find one of the missing sides. Now, one thing that you would not have looked at in algebra is common PT, like the triples. Pythagorean theorem, triples, and then their multiples. So what it means by triples, if we have, like with this first one, if we have a triangle where the legs are 3 and 4, then what would the hypotenuse be? Would be 5. Yep. And then, like it says, any of its multiples. So, like 6, 8, and 10 are all multiples of 3, 4, and 5. Also, like it says, if we had a right triangle and it was 8, 15, then what would the hypotenuse have to be? 17. Yep. Now, it's not like I'm going to quiz you on this. Say, if you have a triangle that has legs 7 and 24, what does the hypotenuse have to be with the, if you look at your Pythagorean triples, right? This is just to make it so you can solve these a little bit quicker. You could very easily only have this, and then you could just set up a squared plus b squared equals c squared, and you would end up getting 25. So if you remember these, it can be a little quicker. If not, it's not the end of the world. So if we look at our first example, find the value of x, tell whether the side lengths form a Pythagorean triple. Well, we have 12 and 5. So if we look at our chart, what does the hypotenuse have to be?
13.
13. Yep, because we have 5, 12, that matches this first one. 5 and 12 are our legs, so x would have to equal 13. yes, we do have a Pythagorean triple. Questions? Find the value of x. Tell what the side lengths form a Pythagorean triple. So if this is a, now would x be our like second leg, or is that our hypotenuse?
Second leg.
Second leg, so that would be b. Here is c. 7 squared plus b squared. Well, we can just call it x. Someone find 14 squared for me. 36? Now, just like in the warm-up, to solve, we need to get x by itself. So what's 196 minus 49? And our last step, again, just like in the warm-up, would be to square root both sides. Which that's going to be some decimal. So most of the time, what was it, 12 point what?
12.1, 2, 4, 3, 5.
So most of the time, I mean, if you leave it, unless the directions explicitly say like round your answer to the nearest tenth or something like that, if you leave it in the square root form or write it, just round it off, then that would be okay. If it's a perfect square, then you need to know that. Like if it were the square root of 144, then I would expect your answer to be 12 for you to simplify. Now to answer the second part, is this a Pythagorean triple? Without even looking at our table, we can say no, it's not, because the Pythagorean triples don't have any decimals involved, right? They're all clean whole numbers. So no, this is not. All right, there you go. There's two problems. That should be the first slide since I didn't have the warm up on there like I thought. Go ahead and work on those. Like I said, you've got all the theorems on your note packet. The only thing you might want to add to that on those pages are some examples. Also, for those that didn't notice, we have beans now in our room.
Are they actually sprouted?
Yeah.
They're not going to be here to water them.
Can you see them? Well, someone watered them really good. So it's going to be okay. But if anyone gets hungry during class, then just let me know.
We're going to
Beans.
have
A bean feast. Sure.
That's cool.
A beast. Yeah. That's clever.
Jazz
We'll go about 30 more seconds. X squared equals 2. Yeah. So we need to get x all by itself.
I got it.
So we need a square root. To get rid of x squared, we need a square root both sides. Yep.
25 minus
1.
Well, square root of 2 is a messy decimal. A lot of people do think square root of 2 is 1, but you would leave it as the square root of 2.
Why not? X squared. And it's a perfect square.
Or a perfect triangle, triple plate.
So that's what we should see for the second one. Keep moving.
I know we have our
Our next theorem, 9.2, is the converse of the Pythagorean theorem. So remember, the converse is like switching the order of things, right? I would say something like, if Braden studies for his test, then he will get an A. Right? That might be our statement. The converse would be, if Braden gets an A, then he studied for his test. So we're switching the order of things. So with the Pythagorean theorem, we're saying if we have a right triangle, then we can set a squared, b squared, c squared up. Now we're going to look at the converse. So if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So what we'll see with the converse is they'll say, hey, we have a triangle that has side lengths of 3, 4, and 7. Could this be a right triangle? Okay? So we'll set up, we have to have the longest side equal to the two shorter sides. And if these are equal, then we have a right triangle. If they're not equal, then we're out of luck. We do not have a right triangle. So here's what our example looks like. Again, the only thing you might want to add to that note packet is a couple of examples next to those theorems. And this would be, go with theorem 9.2, converse. So tell whether each triangle is a right triangle. Well, we take letter A. We first need to figure out what is our longest side. 7, 8, or square root of 113. What do we think was our longest side? Yeah, what does that give us about? What again? 10.6 we'll say. So we know that that's our longest side. So we're going to set up the Pythagorean theorem. So 113 squared, square root of 113 squared equals 8 squared plus 7 squared. So if these are equal, then we have a right triangle. If they are not, then we do not. So we have 113 equals 64 plus 49. What's 64 plus 49? Who's got a calculator?
Maybe 100.
What is it? So they are equal? So then that means we have a right triangle. Now with this other problem, even though I know you guys are getting the idea of how to set this up, I understand this isn't overly difficult. Stay with me to look at this example B, because a good algebra concept comes out of letter B, and it's something that is easy to miss when we are setting these up. So we can see that this is our longest side. Even though it totally looks like our longest side, I would still double check to make sure. So what is 4 multiplied by square root of 95? Anyone? 4 times square root of 95. 38 point something. So 38 point something, we know it's our longest side, so we're all good there. Now, when we simplify this, we need to make sure that we give the square to both 4 and the 95. Now, we could just plug in our calculator. I guess there's two ways to look at it. We could just plug in our calculator 4 times square root of 95, get that number and square it. But if you were to do this by hand, you have to make sure that you write it with that square to both numbers. So, again, what I would do is just plug this into my calculator and square that decimal, that 38 point whatever. But if you were to do it by hand, make sure you distribute that square. So either way works. Ethan, why don't you get the 4 times root 95 squared, and someone else get 36 squared, and someone else get 15 squared. So I need 3 people to find something.
36 squared is 1,686.
Correct? 225. What about that other one? Just round it to the nearest 10. So you got it. 4 times the square root of 95, and then square that number. So we want to be a little careful. So I type in 4 times square root of 95. You get that decimal. Now I just square that. What decimal? What is that? 15, 20. What do we get if we add 1296 and
They are
2?
not equal.
What?
They are not equal.
Well, what does it give me on the right side?
1,501.
So we do not have a right triangle then. Those are not. Does that seem kind of familiar? You did look at that in algebra, but I know you guys were, yeah, you were virtual for it. So go ahead, tell whether those are right triangles. Do they have to give you the picture, or if they just gave you the numbers, could we figure this out? I mean, the picture is nice, but they could just list the 3 numbers, and you could find it. That's what we will get to. And they might do in some problems. We have one more theorem or 2 more? Yeah, just one more theorem. After this, one more theorem, 1 example, 1 practice, and then that's it for today. Yeah. Yes. Yep. Like I said, what I would do, like if for me, I would type in 3 times square root of 34 in my calculator, and then that'll give you some number, and square that number.
Okay.
Whatever you get after you want.
And then do you just
So, like I said, if you would go, I think square root. So there's that, and then I would just square it. Yeah, I don't know what to square that. Well, you just square root it.
Oh.
So you want to square it, raise it to the 2nd power.
Mr. Lane,
What's the matter?
I got 306 for these and 309. But there's also decimals in it.
Well, when you 17,
Good.
4, 9, when you square it, you got exactly 305. No, what did it? What number is that?
Number 4.
Number 4?
I got 305.9999.
You get?
305.9999.
Yeah, I got 305.
Round up. You can round it. Round to the nearest whole number.
So they're right.
Yeah. Yep. Just wait for about 30 seconds and we'll move on. This is part of the reason why, I mean, I know a lot of you guys use the iPad calculators, but these calculators is nice because if you plug in, you can see here, you have 3 times 34, square it, it gives it to you clean. I don't know if you guys can see the last 2 lines of what I plugged in, but it gives it to you clean. Right, it gives you 306 exactly. You can use these calculators instead of worrying about rounding. 3 times root 34, so the decimal square it, 306 exactly. The last 2 lines. So, again, the iPad calculators are okay, but this gives you, I mean, there's no question when you look here. We type in, let's see if we're set up. Oh, yeah, you did get that. Okay, perfect. Yep. All right, last theorem. Where's my iPad? You guys are doing good. Last theorem, last example, and you got one more slide. You might even have some free time in class. Free time. No homework today. We're going to start class with it tomorrow. Pythagorean theorem Pythagorean inequalities theorem. This is not something that I think you looked at in algebra. I think this is probably new. If c squared, remember our hypotenuse, is less than a squared, that should be b squared, plus b squared, then the triangle is acute. So if our hypotenuse squared is less than our two legs squared and added together, then we have an acute triangle. Well, let's backtrack for a second. What did we just talk about? If these are equal, what type of triangle do we have? We have a right triangle. Yep. Now we're saying if c squared, so here, if it's less than a squared plus b squared, then the triangle is acute. If c squared is greater than a squared plus b squared, then the triangle is obtuse. Which makes sense, right? Because if our hypotenuse is super long, if it's greater than a squared plus b squared, then that would make sense that the angle of our triangle is really wide. So hopefully we kind of see how that clicks. And that theorem should be on your page as well. Actually, it might be on both. There it is. It kind of makes sense. I think that should click. If we understand what's going on with the Pythagorean theorem, that if these are equal, we have a right triangle, then we can see how c squared is less, we have acute, c squared is greater, we have obtuse. So here's a perfect example of the homework question. Verify that segment lengths of those three lengths form a triangle. Is the triangle acute, right, or obtuse? So how are we going to set this up? What's our setup going to look like? Any ideas?
Any on class to the counseling office thing?
She is virtual.
Okay, thank you.
Depending on class. I can see how you get that. If we said verify that this is a right triangle, what would we do? What would our setup be? We have three side lengths here. If we're trying to figure out what type of triangle is this,
Do 6.1 equals 5.
right? The point is we need to get our longest side on one spot, and our two other sides, our two shorter sides on the other spot. Now there is one thing that I skipped over, and I don't know, did I miss a theorem? Did I forget to put a theorem in here? I might have. There's one thing we need to do before we can decide what type of triangle that this is. It says verify that these segments are a triangle. So to verify that segments are a triangle, and this might be something that, an example you want to write down, because I don't think that this theorem is included in the packet. But to verify that something is a triangle, we need to make sure that each side length, so we're backtracking for a second, we'll get to this after we verify that it's a triangle. We need to make sure that each less than the other two sides. So we need to verify that each of these is less than the other two added together. So this is how we verify that lengths even create a triangle. By taking each side and making sure it's less than the other two added together. So there's two parts to this question. First, verify that it even forms a triangle, that it's possible that this forms a triangle. Then we need to tell what type of triangle this forms. So if we just look at the whole numbers, we can see pretty quickly that this all is true. I mean, 4 plus 5 will give us 9, and 9 is definitely greater than 6. So we're good here. 5 plus 6 is 11, way greater than 4, we're good. 6 plus 4 is 10, way greater than 5, we're good. So we don't really have to get picky and type in all those little decimals and stuff, because we just need to make sure that these two sides are greater than whatever the third side is. So we just verified that this is a triangle. Now we can look to see, okay, what type of triangle is this? Well, we take that longest side and we need to decide, is it greater than, less than, or equal to the square of the other two sides? So, let's see. Nate, why don't you find me 6.1 squared, Jack 4.3 squared, and Mia 5.2 squared. Once you get it, just let me know.
5.2 squared is 27.04.
Okay?
4.3 squared is 18.49. And that's 37.
Now let's see, Anastasia, see you have your calculator up. Why don't you add together 18.49 and 27.04? So let's see, 37.21 is less than 45.53. So what type of triangle does this have to be? This would be an acute. Again, I kind of went out of order, and that's my fault. First, we had to verify that we had a triangle by checking all the sides, which we have done in the past. It's been a while, but we have done that before. And then we need to decide, all right, what type of triangle is this? If you haven't already, go ahead and move on to the last slide, and that will be a wrap. Get that class pick done so I can take a look at it, make sure we're all on the right track, and then tomorrow we will start out with some PT homework.